Hello students, I am Latika Leekha. I am gold medalist in MPhil and associated with askIITians as mathematics faculty for the last 3 years. So now I will be beginning the chapter on complex numbers. I have split up this chapter into various parts, like first of all we will be beginning with the definition of complex number and then the classification of complex numbers. Once we are done with that, we will be moving to the algebra of complex numbers. That is, we will be studying the equality of two complex numbers, the addition, subtraction, multiplication and division of complex numbers. Then we will be studying how to compute the square root of a complex number. Then after we are done with this, we will be moving to the three important terms related to complex numbers, that is, conjugate of a complex number, modulus of a complex number and argument of a complex number. Please notice that argument is an extremely important topic and it can be a bit confusing too. Okay, now once we are done with that, we will be moving to the geometry of complex numbers and de Moivre's theorem. We will also study the cube roots of unity and nth roots of unity. And finally, we will be discussing some of the previous year questions of complex numbers, just to give you a brief idea about the types of questions that you can expect from this chapter. So, first of all, in the first part, we will be beginning with the definition and the classification of complex numbers. So, let's begin.
Okay, so now we'll be beginning with a very important chapter, which is complex numbers, and it becomes all the more important because it lays foundation for various other chapters, right? So, let's begin. First of all, we shall discuss what exactly do we mean by a complex number, and even before that we'll discuss how did the concept of complex number come into existence. So, see, as far as the concept of complex numbers is concerned, first of all it came into existence because, as we know, that we do not have any real number x in order to solve the equation, that is a real number x which satisfies the equation of the form x square plus 1 equal to 0, right? I'll explain to you. Like suppose I have an equation of the form x square plus 1 equal to 0, and if I need to find out the value of x which satisfies this equation, I cannot get any such real number x, because if you see, this means x square is equal to minus 1. So how can we have a square of a quantity as a negative number? This is how the concept of complex number was introduced. In order to solve such type of equations, we introduced a symbol which is denoted by under root of minus 1, which we call it as iota. This I stands for iota, right? So, in order to solve such equations, we introduced this symbol under root of minus 1, which we denote by I, that is iota, and it was introduced to provide a solution to such equations. Iota was basically a fictitious or an imaginary number, right, which could be manipulated like any other, algebraically like any other ordinary number, except for the reason that its square was minus 1. So now we begin what we mean by a complex number. A complex number is defined to be the number of the form a plus ib, I is iota, where a and b are real numbers. It is generally denoted by z. This is basically how usually we denote a complex number as, right? We generally denote a complex number by the symbol z, z equal to a plus ib, where this a is called the real part of z and this b is called the imaginary part of z. So this a is called real part of z and we denote it as re, in brackets we write z, and this b is called the imaginary part, which is denoted by im, that is imaginary, and in brackets we write z. So this was what we mean by complex number. Now we'll discuss the classification of a complex number. So as we have discussed, every complex number can be classified. We can write a complex number as z equal to a plus ib, I is iota. So how do we classify complex numbers? Just see here, I have written z equal to a plus ib. Now this complex number will be termed to be purely real. Just now we have discussed that A is the real part and B is the imaginary part of the complex number Z. So we'll term it as purely real if B is equal to 0. What do I mean by that? See, in this number, if I take B to be equal to 0, so this will become A plus I into 0, that is A. So this is only the real part, and therefore we'll term the complex number Z to be purely real. Similarly, if we want purely imaginary, this is purely imaginary, we'll term it to be purely imaginary if A is equal to 0. Now in this I have A equal to 0, and therefore that means I have 0, Z becomes 0 plus IB, that is it's IB, and B is the imaginary part, so I have it as purely imaginary, and we'll term it to be imaginary if B is non-zero. Since B is the imaginary part, if we have B to be non-zero, we'll term the complex number Z to be imaginary, not purely imaginary but imaginary, since we are restricting only the value of B, that it should be non-zero. Now, I hope this would be clear. This is quite simple. On the basis of it, we can say that if we have a complex number 0, that is 0 plus 0I, we can term it to be both a purely real as well as purely imaginary complex number, right? Since we have, if B is 0, we can term the complex number to be purely real, and since here B is 0, so we have it as a purely real complex number. Similarly, if A is 0, we can term the complex number to be purely imaginary, so we have this complex number to be purely imaginary. But at the same time, you cannot term this complex number 0 plus 0I to be just imaginary, because we don't have B to be non-zero, right? Here we have A and B both are zeros, so we cannot term it as imaginary, but it will be both purely real and purely imaginary. So classification was quite simple. I hope this must be clear by now. Now we have the geometrical representation of a complex number. That means a complex number may be represented as a set of ordered pair AB on the plane called the complex plane or the Argand plane. We term this plane to be complex or the Argand plane. Now suppose I have a complex number of the form Z equal to A plus IB. So what I'll do is, this we can write as ordered pair AB, and this ordered pair automatically denotes that A is the real part of A and B is the imaginary part of Z. A is the real part of Z and B is the imaginary part of Z. So how do we denote it? We'll take this as this is my x-axis, this is my y-axis, that is this is the imaginary axis, this is the real axis. So you'll take this distance to be A, since A is the real part. So on x-axis take a distance A, on y-axis we have this distance is B, and this becomes my ordered pair AB, that is A plus IB. This is my complex number A plus IB. So we have just now discussed, we write a complex number as A plus IB, but here you can see we have written A plus BI. So you can either use this way or you can denote it as A plus BI also, but most commonly used notation is A plus IB, that is we write the real part plus iota times the imaginary part. Now we have the integral parts of I, and this is extremely important. This will be used in various questions. Throughout complex numbers, we will be using this integral parts of iota, integral parts of iota. So as we have discussed, iota is under root of -1, right? Now if I have to find out iota square, that will be -1, under root -1 into -1, that is -1. So just remember that iota square, whenever we say, we mean -1, right? Similarly, if you are supposed to find out iota cube, that will be iota square into iota, that will be -1 into iota, that becomes minus iota. This is minus iota. And if you are supposed to find out the value of iota 4, that will be iota square into iota square, -1 into -1, that becomes 1. So we have iota raised to the power 4 is 1. So just remember these iota square is minus 1, iota cube is minus iota, and iota raised to power 4 is 1. And on the basis of this, you will be able to solve numerous questions, right? So, and on the basis of it, we can say iota raised to the power 4n plus 1 becomes iota. How? Because you can write it as 4n into iota, and that becomes iota in 1 into iota, that is iota, right? So, similarly, iota raised to the power 4n plus 2 becomes minus 1 for any n belongs to I, and iota raised to the power 4n plus 3 becomes minus iota. And so, iota raised to the power 4n will become 1. Using these conditions only, iota square is minus 1, iota cube is minus iota, and iota raised to the power 4 is 1, we can derive these. And on the basis of this, you can solve out questions. Thus, for any integral power of I can be expressed as either plus minus 1 or plus minus iota. So, that means if you have any integral power of iota, you will get it as either plus minus 1 or plus minus iota. So, now we have a question based on this. Find the value of iota raised to the power 592 plus iota raised to the power 590 plus iota raised to the power 588 plus so on plus 2. Okay, so some of you might have got confused seeing this whole huge question, but this question is very simple. On the basis of this only we will be solving it. So what I can see is I can take out iota raised to the 584 common from the numerator, and I am left with iota raised to the power 8 plus iota raised to the power 6 plus I have iota raised to the power 4, iota raised to the power 2 and 1. Similarly, from the denominator I can take out iota raised to the power 574 as common, and then I have again iota raised to the power 8, iota raised to the power 6, iota raised to the power 4 and iota raised to the power 2 plus 1, and plus 2 is as it is. This is what we get. Okay, so this whole term gets cancelled and we are left with iota raised to the power, this becomes 10 because I can take this common and this powers get subtracted. So I have iota raised to the power 10 plus 2. This is equal to, I have already discussed, whenever you have iota raised to the power something, try to reduce it in the form of iota raised to the power 4, because that will become 1 and you will be able to reduce that question. So what I do is I can write it as iota raised to the power 4 square into iota square plus 2. So this becomes 8 plus 2, that is 10, right? So this is how I break up this term. Now I have 1 square into minus 1 plus 2. How 1 square? Iota raised to the power 4 is 1, so I have 1 square. Iota square is minus 1, so I have minus 1 plus 2. So this becomes minus 1 plus 2, that is 1. So the simple answer is 1. So see, this question was quite simple. You just need to remember these powers. And in fact, if you don't even remember these powers, you just need to remember this value. Obviously, you will remember iota is under root of minus 1, and so iota square is minus 1. Even on the basis of this, you will be able to solve out such questions.
So in this part we discussed what exactly do we mean by complex number, the classification of a complex number and the integral powers of iota. In my next session, I will be switching to algebra of complex numbers, that is, we will discuss equality of two complex numbers, addition, subtraction, multiplication and division of complex numbers. So stay tuned.